Well, by the late 30s, physicists in Europe primarily, but some in America too, were making great discoveries about the atom. The key date here was January 1939, when European scientists had discovered fission. And news of that was brought to the United States by Niels Bohr. Actually, it was brought to Washington, D.C. at a conference at George Washington University, and Bohr and his fellow scientist Enrico Fermi and others announced it to the assembled, and immediately everyone knew that something very significant had happened, and possibly even something very fearful, in that this new discovery could be turned into a form of energy, vast destructive power. So just at the same time that World War II was about to begin in 1939, and of course it did begin in September 1st, 1939, this new discovery of physics came at the same time, and they share then the history of the war from then on.
Just because it makes a good visual, can you, you mentioned the conference in Washington, D.C. Can you just mention that to verify this new phenomenon, they went to the Carnegie Institution in Washington? Mm-hmm. We have that one photo.
Okay. At the conference at George Washington University in January 1939, in which most of the famous scientists and physicists in the world were assembled, upon the news of the fission discovery in Europe, all of the scientists in the United States saw that it was a major breakthrough, and many went to the Carnegie Institution of Washington to verify the experiments again and reconfirm what Bohr had just told them.
I want to get Carnegie in there. Let's see. Maybe you can then talk about Albert Einstein and his letter to Roosevelt.
Mm-hmm. Well, after this new knowledge had become widespread among the scientific community, a few of them decided that something was going to have to be done to alert the government and alert each other about the implications. So Leo Szilard, a Hungarian refugee who had made his way to the United States, Edward Teller, also Hungarian, got together and decided that they would alert the most famous scientist of the day, Albert Einstein. And in the summer of 1939, they drove out to Einstein's summer house and had Einstein write a letter to President Roosevelt, alerting him of the significance of this discovery. And through an intermediary, a man named Alexander Sachs, they got the letter delivered to Roosevelt, and that's usually considered to be the first step in the United States government's effort to begin working on the bomb.
Now I'd like you to talk about, I suppose we could talk about the Maude report. You can throw that in if you like. Mm-hmm. And then talk about Roosevelt's creating the Office of Scientific Research and Development.
Okay.
Choosing Vannevar Bush.
Okay. Well, after Roosevelt had received this letter, he committed a small amount of money to an effort. But in the United Kingdom, in Great Britain, their scientists were actually far ahead of American scientists in working on a lot of this. They put together a government committee that became known as the Maude Committee, and issued a report known as the Maude Report. And in there, the scientists concluded that a very small amount of a certain isotope of uranium could produce a very large bomb. And this happened in the summer of 1941. And news of this came back to Washington. And Franklin Roosevelt's science advisor, a man named Vannevar Bush, who oversaw the Carnegie Institution of Washington, of course, but then also the government's effort to begin to mobilize science for a war effort, Bush was briefed about this conclusion that they had come to in Great Britain and was highly impressed with the possibility that this now may become a reality. And that's a kind of key date in the history of the decisions about the bomb. So Bush then feels more confident in going to Roosevelt and telling him that this is a serious matter and we have to commit more resources to the effort.
What was, maybe you can talk about, how Bush then, looked to industry, all of that.
Right. Well, by the middle of 1941, the effort is becoming more and more serious. More scientists are involved in investigating this special material, uranium, and how to gain a certain kind of uranium that would be useful for a bomb. And as 1941 wears on towards the end of the year, Bush is more convinced that this is going to be a large effort and we're going to have to recruit the Army to do this. We're in the midst of a very large mobilization at this point. Many people, including Roosevelt and Secretary of War Henry Stimson and George Marshall, are all quite sure that war will happen eventually, and preparations are being made in many ways through the draft, through munitions plants, and so on and so forth, to prepare for this war. Actually, on the eve of Pearl Harbor, on December 6th, Vannevar Bush and some other scientists decide that it's time to really recruit the Army into this effort. And of course, the following day is Pearl Harbor, and everything has changed dramatically. But it's really towards the end of 1941 that the government is now really committed on a large scale and signs up the Army to do the job.
Great. Do you want to leap to...
As we go on, okay.
Yeah, go ahead.
Well, after December 6th, of course, the country is faced with now Japan being the enemy in one theater in the Pacific, and Hitler declaring war in the United States at approximately the same time, and now committed to a European war as well. And everything needed to be done with vast numbers of men to be trained and sent abroad. And the bomb effort sort of lingered for a few months. And it's not really until mid-1942 that Bush again gets the ear of Roosevelt and Stimson and Marshall to get really serious about it. And it's at that point in June of 1942 that the Army chooses the first director of what will become known as the Manhattan Project. And that was a colonel named John Marshall, a Corps of Engineer, West Point graduate. And in June, he begins to do some things to mobilize industry and science and the military towards building the bomb. But throughout June and July and August, he's not moving very quickly. And Vannevar Bush and his counterpart, President of Harvard, James Conant, are dissatisfied at the pace of activities, that if this bomb is going to make a difference in this war, it's going to have to move faster. So Bush and Conant press Stimson and Marshall to find someone else who can move at a quicker pace. And it is at this juncture that the Army chooses another colonel, Leslie R. Groves. On September 17th, 1942, Groves learns of his new assignment, is not terribly happy about it, but being the good soldier that he was, he salutes and takes the job. So these are the crucial dates in the formation of the Manhattan Project. Groves, at the time, was basically John Marshall's boss, and thus he knew some of what was going on or not going on. They were already surveying the site at Oak Ridge, Tennessee, and thus Groves had quite a bit under his belt already, even before he got the job, in the way of knowledge. But on September 17th, it's now in his hands, and it's really rather breathtaking to watch Groves over the next couple of weeks make enormous decisions that will be crucial in the formation of the Manhattan Project and its organization. And of course, one of those decisions early on, within the first couple of weeks, is to choose to think about DuPont as the participant in this effort.
Great. One thing, if you could mention, and we can always splice it in, that Groves built the Pentagon, because everybody will recognize that.
Okay.
And then you can talk about, the DuPont.
Right. Well, of course, the reason why Groves was chosen was that he had already had a track record for the past 2 years. Basically, he was in charge of all Army building projects during the mobilization period, from about mid-40 to mid-42. This was an enormous undertaking, which actually is about 4 times the Manhattan Project if you total up the money. At the peak month, which is July 1942, Groves oversaw over $700 million of projects and had 1 million men working for him. And among those 100 plus projects, which included munitions plants and Army camps, airfields, depots, one of them was the Pentagon. And this is I suppose, the second thing that Groves is known for. In September 1941, just on the eve of what will be Pearl Harbor, the War Department decides to consolidate itself under one roof from buildings all over town. And in rather dramatic fashion, they lay out this enormous building. And ground is broken, coincidentally enough, on September 11th, 1941. And in 6 months, the first people move in to the first wedge, to the first section. And in 16 months, the building is done. And of course, the building remains today one of the largest office buildings in the world. And Groves oversaw its construction, sort of like an Egyptian pharaoh, with 15,000 workers working around the clock to get it done. And it stands today as a testament to American know-how in getting something done quickly, and Groves was always proud of that feat as well. Again, among those many projects that Groves was overseeing in 1940, 41, and early 42 were munitions plants. And he knew DuPont because I believe he built 8 munitions plants with DuPont over the course of time here. And thus, Groves knew the executives at DuPont and Wilmington. He knew their engineers, and was very impressed with the way they got things done. And basically, DuPont was his first choice when he decided to have a facility for the plutonium production. And that came about, as I said, in September and October and November of 1942. Groves called some executives down to Washington, to his office, and informed them of his wishes that he wanted DuPont. They carried the news back to Walter Carpenter, the president, who probably not too happy about this, with a full plate of their own already, and now being asked to participate in something that was quite uncertain and had the potential for failure. But nevertheless, Groves pressed on President Carpenter, and Carpenter went to his executive committee and said that the Army, the country needs our help. And without really knowing what it was that they were signing up for, the executive committee, they gave Groves the okay. And thus, DuPont was on board for the grand sum of $1. It was the beginning of DuPont's involvement in the Manhattan Project. General Groves in these first few months here was making enormous decisions about where to put the factories that were going to produce the atomic materials for the bombs, about where to establish a laboratory, about what personnel were going to work on it. And after he decided not to put this plutonium reactor or pile at Oak Ridge, he had to find another place for it. And in December, he sent one of his trusted aides, a man named Franklin Matthias, and two DuPont engineers, one who will become very, very involved, a man named Gilbert Church, out to the West Coast to look at a series of sites that were possibilities. Now, they looked in the Pacific Northwest, and on December 22nd, 1942, Matthias got a small airplane and he flies over what will become the Hanford site in southeast Washington. And he knows immediately that this is going to be the place. It fit all of the criteria that Groves wanted. It had to have an abundant source of water. Of course, the Columbia River is there. It had to have an electrical system nearby, and the Bonneville Dam was there, just complete in the Grand Coulee. It had to have a mild enough climate so that work could go on pretty much all year round. And in the high area of southeast Washington, that fit the bill. It was quite isolated, and for Groves's penchant towards secrecy and everything, that was good as well. So Matthias called Groves immediately afterwards, and it was pretty much settled by the end of the year. Matthias comes back with a report. Groves is fairly convinced that that's the place, but wants to see it for himself. So he goes out in mid-January 43, looks it over, and concludes that this will be the place. And at that point, the government takes over a vast area of land. This is a 500 square miles. It will eventually be half the size of the state of Rhode Island. And ground begins to be broken at Hanford for what will be initially 3 reactors and 2 chemical separation plants that will be the place where plutonium is produced. And at this point, Hanford, the little town that was there, is sort of transformed, and eventually, I think at the peak, there are more than 50,000 people at the Hanford site, the workers constructing the place and everyone else. And DuPont is there not only to design and build the plants, but also Groves demands that they operate them as well. So they're in for the complete range of activities at Hanford, and do them all very well. DuPont was a good fit for Groves's plans here to oversee plutonium production. And of course, the story of the bomb is not just a story of physics, it's also a story of chemistry and engineering and many other things. But DuPont was, of course, very well known as a chemical factory, had done a great deal, did a great deal in munitions work, and Groves was attracted to that, and also to what he saw in the way that DuPont was managed itself and managed projects. Later, this will become used by everyone, but in the 1930s and early 40s, it was something rather new and really almost unique, I think, with DuPont. The phrase that's used is the critical path scheduling or critical path method. And what it means is a very attentive, structured way of going about whatever you're doing here. Every worker knows exactly what he's going to be doing that day. There's follow-up to see that he's done it, a lot of quality control. And these were the things that Groves saw about DuPont in the building of the munitions plants. And he knew that this was a more efficient way of managing a large industrial enterprise. And thus, to put it into place to build something as experimental as atomic piles and chemical reprocessing was going to cut down on the uncertainty of whether or not it would be done. So I think this is Groves's insight into DuPont's way of doing things that is another basic reason why he chose them. And of course, much that went on at Hanford is related to chemistry, metallurgy, and the chemistry of plutonium extraction and so on. So the chemists also play a major role in the Manhattan Project, and it's not just the physicists who have gotten most of the limelight, but the chemists deserve their share as well.
Okay. Can you talk about Crawford Greenwald and the reviewing committee and how they went out, but DuPont wanted to make sure that they could get the least likely to succeed process assigned to them, that kind of thing?
Well, Groves was making all of these decisions here, but he hadn't always convinced everyone else who needed to be convinced. His superiors like Vannevar Bush and Conant and some others who may have been hesitant about all of this. So in time-honored fashion, he assembles a committee to look into a matter, and this is in November and early December of 1942 to really see if the things that are now going forward here are the right things. And among the participants in this is, or among the, I guess the basic audience for this will be Crawford Greenwald, who is based in Wilmington, and will become a person who provides a kind of liaison and intermediary between DuPont in Wilmington, DuPont in Hanford, and really the third leg, which is what goes on in Chicago. Because at the University of Chicago, at the what's called the Met Lab, or the Metallurgical Lab, are assembled a bunch of scientists and chemists and engineers and physicists who are the support for many of the blueprints and designs and concepts upon which Hanford will be built. So Greenwald, Crawford Greenwald plays a key role and in all of this. And by the end of the year, certainly in 1942, as a result of this committee that Groves had formed, which basically supported these decisions, everyone is on board and convinced that the project has a chance of working and it's worthy of going forward. Of course, uncertainty hung over the whole thing from beginning until July 16th, 1945, when the first bomb was tested in New Mexico. So in retrospect, it all looks as though it were inevitable and going to happen, but trying to put yourself on the other end, there was uncertainty and fear of failure at every juncture. And that must have been felt by all of those involved, including General Groves and Crawford Greenwald. Greenwald had already had a sort of track record himself within the DuPont company of working on, I believe, the nylon project. And I don't know, seemed to have the kind of personality that was right for the job. Among General Groves's skills, in addition to the managerial ones of overseeing big projects, he was a pretty good judge of character and sizing people up almost immediately to know whether or not they were right for the job. And in meeting Greenwalt, I'm sure he was impressed and saw in him what was needed for this task, which was to keep the scientists working, keep them calm under actually what some of them thought was rather strict discipline. They were part of an army project, for example. They were to work in great secrecy, the very opposite of the scientific credo. So Greenwalt was there to smooth the feathers of the scientists and make everything go smoothly. And he and Groves got along very well throughout the whole course of the war. In fact, even after the war, there was some thought of perhaps General Groves going to work for DuPont, but he never approached his old friend Crawford Greenwalt to ask. But at one juncture, though, he did have to discipline Greenwalt. Greenwalt had begun to write a diary, in secret, actually. And that diary exists today and is in the Hagley Museum in Wilmington. And Groves had ordered across the board that no one was to keep a diary. And when he found out that Crawford Greenwalt had been keeping a diary, he ordered him to stop. And Greenwalt, being the man he was, stopped immediately. And thus the diary comes to a rather sudden end and is not continued. Well, one very good example of DuPont's approach to projects is the example of when they turned the first reactor on at Hanford. This reactor was designed by a group of scientists in collaboration with DuPont engineers and scientists. And it was decided to put roughly 2,000 tubes into the reactor that would be filled with uranium rods. And when those began to go critical, of course, that's the process out of which plutonium is produced. Now, in September of 1944, as the reactor was finished and they first turned it on, it started up and then it stopped. And everyone thought that what could the problem be? And the problem was that they had only filled about 1,500 of the tubes with uranium rods. And through a process of what goes on inside the reactor, xenon, X-E-N-O-N, is produced, and it sort of poisons the reactor, and it causes it to stop. Now, had the reactor been built with only 1,500 tubes, the reactor never would have been able to work, and plutonium would not have been ready less than a year later for the bombs at Trinity and Nagasaki. So basically what you can say is that DuPont took an approach of sort of always overbuilding whatever it was. If a building was going to be 3 stories, they'd make the construction strong enough to have 5, since probably at a later date they'd need that. And here they built a reactor with 2,000 tubes, and eventually, after this poisoning incident, they halted the process and they filled the other tubes. And when they started it up again, it was powerful enough to overcome this poisoning, and it worked as it was supposed to. So this would be a good example of competing ideas about how to build something. And the scientists, actually, many of them, were for building the smaller one. It would have been quicker, faster, maybe less expensive. But Groves heard DuPont out, and being very conservative always, decided to go with the larger one. And it's a good thing they did. And otherwise, the bomb would not have been ready and used when it was.
Can you talk about the chemical separation plant and the novelty of trying to do something with radioactivity and using remote control operations?
Well, of course, a plutonium production reactor is highly radioactive, and after it is irradiated inside the reactor, the fuel is pushed out the back and sits in a cooling pool, and then is transported to a chemical reprocessing plant where the plutonium that is bred inside the reactor in the tubes is separated from the uranium. Now, all of this is a very, very messy business here. This is highly radioactive, highly hazardous, and human beings can't be in direct contact with this. So all of this had to be done through remote control, basically, with little carts, little trains taking the fuel from the reactor to the chemical processing plant, through the use of remote control arms, and even the use of television. This is one of the early uses of sort of industrial television to separate this plutonium in these acid baths and extract the very, very tiny amounts of plutonium from the very, very large amounts of uranium fuel. So chemical reprocessing is, right from the very start, very, very messy. And of course, from that day until this one, since we continued to do this at Hanford and a couple of other places throughout the Cold War, we produced an enormous amount of radioactive high-level waste. And much of it still sits in the same tanks that were built in the Manhattan Project. And this legacy is still something we're grappling with, trying to figure out what to do with it.
I'd like to have you talk more about the health and safety issues and environmental issues and what was known and not known and how things were handled.
Right. Well, from the outset, the scientists, and I think General Groves himself, knew that the potential for accidents and hazards of one kind or another around these radioactive materials and on this huge industrial scale were possibilities. And thus, perhaps, obviously it wasn't the best place to build these huge things in cities or nearby. And Groves set up a medical health section within the Manhattan Project and recruited doctors who had some knowledge in this new area of public health having to do with radioactivity. The person he signed up was a University of Rochester doctor named Stafford Warren, and he oversaw studies about health matters. And Groves, I think, sort of symbolizes what's always the case, what always has been the case in the U.S. atomic bomb effort, and that is trying to balance the speed of producing bombs with environmental and safety on the other hand. The more environmental concerns and things about safety are going to slow down the production of bombs. So this is always something that is managed over the years. And Groves was, I think, probably fortunate that no catastrophes occurred, although he saw the potential for them. What if one of these piles blew up? What if at Oak Ridge too much highly enriched uranium was in one place and went critical? He had Edward Teller investigate this problem, and Teller came away saying that these separation plants in Oak Ridge were going to be safe and it was okay. But this was always a potential problem. Throughout the course of the Manhattan Project, of course, people were killed in industrial accidents. These large machines took their toll. But all in all, I think the safety record was about the same, or actually a little bit less than what went on in tank factories or other kinds of large production facilities. So it will become more evident after, I think, the bomb is used. The American public and then the world will become aware of radioactivity and become much more sensitive to all of these things and put into place things to try and combat it in the making of the bombs, and then, of course, in things like testing bombs in the atmosphere. That will go on from 1945 up until the early 60s among the superpowers. And finally, world opinion says stop, and there is a test ban of testing weapons in the atmosphere, and it stops. So it's something that we're aware of every day when we talk about these weapons. And it was mentioned before about the Normandy invasion and how the Germans might potentially have some sort of radiological weapon, what today we call a dirty bomb, and perhaps would use that on the invading troops. And Groves alerted Eisenhower of the possibility, and Eisenhower did take some action with his British counterparts to have certain soldiers who stormed the beaches in Normandy have basically detectors on them, and if any of them saw that they had gone off, they were to alert their superiors that something had happened. Of course, that didn't happen, luckily. The Germans had no radiological bomb, but it was a concern even on the D-Day.
I never knew that.
Project Peppermint, it was called. Project Peppermint.
He was what?
The operation was called Project Peppermint.
Project Peppermint.
Peppermint was, yeah.
Fascinating. That's great. We can
So how did the fear of what was not known about what the Germans were doing with their bomb project, how did that fuel the Hanford project and the Manhattan project in general?
Of course, from the very outset of the discovery of fission, among the best scientists in the world were Germans. And really from day one, especially in the minds of some of these emigre scientists who had come to the United States, was the fear that German scientists working for Hitler were going to discover this first, and whoever got the bomb could rule the world. So as an incentive from day one, fear of the German bomb project was uppermost in many scientists' minds, and certainly in General Groves's mind. And from the outset, it was Groves's desire to learn as much as he could about the German effort. We didn't have spy satellites. We didn't have overflight of Germany the way we could do some things today to find out what was going on. So every scrap of information was important. And of course, when you don't know something, you fear the worst and believe that your enemy is perhaps ahead of you. And this drove the scientists in their effort to build the bomb as quickly as they could for the United States. And Groves eventually assembled a team, a project that was called Alsos. It's a Greek word that actually means grove, like grove of trees. And it was a scientific military mission with people who were going to be right at the front edge of the invasion, first of Italy and then after the Normandy invasion into Western Europe, who would try and find out really what was going on in the German project. So they first have a mission to Italy. Of course, Italy is an ally of Germany, and perhaps Germany, if they were working on the bomb, recruited Italian scientists. But when some of these Alsos agents got to Rome and talked to Italian scientists, they didn't see that very much was going on. But still, that didn't satisfy Groves. So with Vannevar Bush and other scientists, they assemble a larger team that lands in, actually in Normandy in August of 1944, and they begin to be with the troops as they go through France. And by September, October, and November, as they push towards the German line around Strasbourg, it's becoming evident, finally, with capturing real German scientists now who knew something, that the Germans really don't have much of a bomb project at all. But it's only in about November 1944 that Groves finally is satisfied that the German project is not of any magnitude that's going to threaten the United States. And he keeps pushing on with the Alsos team as they invade Germany on into the early months of 1945. And finally, in April and May, they're rounding up the major figures in the German program, such as it was. And in early May, get the crown jewel, Werner Heisenberg, who is captured. And Groves has 10 of the top scientists under his control. The war, of course, is over now in May, early May. And Groves decides to take these 10 to a safe house in England called Farm Hall. And about July 1st, they're interned in this country house outside of Cambridge. And unbeknownst to them, Groves has the place bugged with microphones. And he wants to listen in on these conversations that the German scientists are having among themselves to discover more about what they may or may not have been doing. So from July 1945 until the end of the year, for 6 months, their conversations are recorded, and these tapes only recently became public after about 50 years. And it's still controversial, but pretty much decided, I think, that the Germans just did not know how to make a bomb. They just had not thought through some of the things in enough detail, had not pushed hard enough to see how it could be done. And I think these tapes show that to be the case. When they learn on August 6th that the United States had dropped a bomb on Hiroshima, Heisenberg and the rest of the scientists are in utter disbelief. How could it be, they say to themselves, when you would need so much highly enriched uranium? And of course, they hadn't thought through the fact that actually you don't need that much. And thus, they were surprised. But after they knew it was done, then Heisenberg went back to his pad and pencil and recalculated, and sure enough, it could be done. But the fear of the German bomb program was a driver from beginning until end for many, many of the people involved in the Manhattan Project. Of course, the Manhattan Project sort of stands still today as a monumental effort to get a project done, to get a goal done in a short period of time. And having written a biography of General Groves, I put much of the responsibility on his effort for mobilizing industry, the military, science, universities, to get the job done. Now, there are basically 3 basic pieces to the Manhattan Project in terms of sites. There's Oak Ridge, where the uranium enrichment took place. There's the laboratory in Los Alamos, where the bomb was to be designed and assembled. And there's Hanford, where the plutonium was going to be produced. And Groves knew at the very outset that the pacing item of all of this was when there would be enough material produced for a bomb. Then the bomb would be ready, and soon after the bomb would be used. And in what strikes me as an absolutely amazing coincidence that the two types of material, the highly enriched uranium that had to be produced at Oak Ridge and the plutonium, which came out of the reactors at Hanford, were both done, or enough of it was done for each type of bomb, two different designs, at approximately the same time. It seems rather remarkable to me that this turned out to be the case. It could have turned out quite differently. If the plutonium at Hanford had been delayed for one reason or another, perhaps those reactors were poorly designed, or there had been an accident or something, the plutonium would not have been ready by the middle of 1945. Or at Oak Ridge, if those factories, very complex, each having their own special features to them, if the highly enriched uranium had not been done at when it was, the bombs would not have been ready in the middle of 1945. So I've always found it to be a rather remarkable coincidence that both of them were done at approximately the same time. I think, though, that the reason that it was done at approximately the same time was through the intervention of General Groves, who drove everyone to their limit to get it done. If we look at Hanford, it goes through, of course, several phases. After choosing the site in the beginning of '43, we have a vast construction effort to build the three piles, the chemical reprocessing, and all of the facilities that go with it. But once those are done, now it's time to operate the plants and to operate them in a fashion to get as much plutonium as quickly as possible. And here you really see Groves's hand in getting the production done. When he learns that the plants are now about ready to begin operation, this is in the fall of '44, he contacts the DuPont people and says, well, what are your schedules here? How much can you produce? Over what period of time will you have enough ready? And they come back with a schedule that shows, well, there won't be really enough until late '45. Groves is, this is unacceptable to General Groves. He says, no, we need it faster. We need to speed up the process. What can you do to speed up the process? Well, basically, there are three things you can do to produce plutonium more quickly in a reactor. You can turn the reactor above its limit. These were 250 megawatt reactors, so you could turn it up to 260 or 270 or 280. You could operate it at a higher level. You could leave the uranium rods in there for a shorter period of time and push them out the back more quickly. That's a second way to speed up plutonium production. And the third way is to leave them in the cooling pools for a shorter period of time. So basically, Groves tells the DuPont engineers and executives, this is what we're going to do. We're going to speed up the production to the limit. And this becomes known as the Speed Up Project. And they accelerate the production of plutonium. And finally, Groves is satisfied that they will have approximately 6 kilograms, which is the key amount they need for a test bomb, by early July 1945. And then they will have another 6 kilograms a few weeks later, which will become the amount for the Nagasaki bomb. So with those schedules in hand, Groves keeps the pressure on, and those reactors are going full tilt, and the uranium is being pushed early. The very hot rods are coming out of the cooling pods more quickly, and plutonium, is in tiny amounts, in just little kilogram amounts, being assembled and taken to Los Alamos. Beginning in February, the first smidgen goes to Los Alamos. And then in March and April and May, convoys of Army convoys literally are physically taking little bottles of plutonium from Hanford, Washington to Los Alamos, New Mexico. But of course the way they are taken is perfectly representative of General Groves's penchant for secrecy and compartmentalization. A convoy leaves Hanford in, they used Army ambulances, and they put these little beakers of plutonium inside special boxes. And they had an armed convoy with lead vehicles, front and rear, with Army couriers with rifles and everything. But of course, the people in the convoy didn't know what they were transporting. And they were told to go to Fort Douglas, which is outside of Salt Lake City, and to meet another convoy, a light convoy, which had come from Los Alamos. And at Fort Douglas, the switch was made, and the boxes containing the beakers of plutonium were put into the other convoy that had come from Los Alamos, and they turned around and went back to Los Alamos. So no one who was involved in the convoy knew what they were transporting, and the ones that had left Washington didn't know the destination of where it was to go, and the ones from Los Alamos didn't know where it had come from. But this was just representative of General Groves's obsession with secrecy and compartmentalization, which went even to transporting plutonium in these months of the spring of 1945.
Not to mention
Yeah,
his
maybe
logistical genius, huh?
Right, amazing. How you described the 6 kilograms for the Trinity device and 6 that would be ready for Nagasaki.
Mm-hmm.
How much more material was there?
Right. Well, after the schedule had been set for first the test device, which would be the Trinity explosion in July 16th, 1945, and then an equal amount for the bomb that will be dropped on Nagasaki, they're able to schedule amounts for subsequent bombs if needed. So if there had been a third bomb, the Hiroshima bomb being the first bomb, Nagasaki being the second bomb, if there had been a requirement for a third bomb, it would have been ready about August 17th or 18th. There was enough material for a next bomb then. And by the end of the year, by the end of 1945, there would have been enough for about 20 bombs. So Groves had them lined up to the end of the year, if need be. There would be a bomb about every 10 days after they got going. By this time, all 3 piles or reactors are going. They're able to schedule things fairly effectively, and we're beginning a process of large numbers of bombs that would be ready. Well, some people have raised the issue that perhaps the scale of the Manhattan Project, this vast enterprise here, was sort of made ready for the Cold War that was to come in the race with the Russians. But I really don't buy that. I think looking at the Manhattan Project and actually the decisions that were made, it could have even been bigger at the time. There were going to be 6 reactors, for example, at Hanford. 3 got built. There were going to be 6 chemical separation plants to go with those 6 reactors, and we end up with 3, one of which isn't used. But there was really just one goal in General Groves's mind, and that was to get a bomb as quickly as possible to be used to have some impact in the war, and that's what happened. He was not concerned about what was going to come afterwards, and the fact of the matter is, of course, that many of those facilities do get used for sometimes decades after the war to produce highly enriched uranium and plutonium for the Cold War arsenal of the United States. But that was not in the plan to begin with, I'm quite convinced. And the immediate goal was to end the war as quickly as possible using this new weapon.
Yeah, that's good. That's good. Sort of wonder why they built them so substantially. I guess it was just the radioactivity.
Yeah, I think so. I mean,
Amazing. They didn't underbuild anything.
no, they didn't underbuild. No, that's for sure.
But it's also interesting that they went ahead and just tore down the whole camp and all the barracks, and I don't know if you went, and S-50 went down, that's Oak Ridge, but if you think about Hanford, how quickly they demolished the World War II structures that were temporary.
Well, of course, the building of Hanford required, I think the peak workforce was in June 1944 with close to 50,000 people there involved in building all of these vast things. The chemical processing plant was 800 feet long, and the scale of everything was of course enormous. But once they were built, there was no reason to have tens of thousands of workers there, and they were let go, and the temporary camp that they occupied was demolished and taken down. But of course, the other facilities were maintained at Richland and so on. Those were semi-permanent for the people who would be operating the plants, the DuPont executives, the Army engineers, and others who carried on with operating the plants, and those facilities still exist and turned into towns themselves that lasted through the Cold War.
Let's see. Now we're sort of beyond my script, but on the other hand, you may have some wonderful things you'd like to add.
Well,
maybe a sort of summary of the accomplishment, you know, sort of summary statement about how this was really an incredible accomplishment in the partnership with industry and academia.
The uniqueness of...
yeah.
Well, many people point to the Manhattan Project as a kind of example of what America can do when it puts its mind to it. And it was this very successful effort at mobilizing the resources of the country, industry, science, the military, and government, and focus it on a goal that was achieved in the amazing short period of time of a little over 1,000 days, about 3 years. And people ask, well, why can't we do that again to solve certain problems? And was the Manhattan Project a unique example of this American can-do spirit, or can it be recreated? And I've come to the conclusion that I think it's really unique. The circumstances were such during the war that just can't be replicated again today. It was done in great secrecy. It was done in the midst of a war, which was one that really was for civilization itself. If fascism were to win, it would have been the end of our society as we had known it. So the stakes were incredibly high. People's commitment to winning the war was at the highest level. Most of the people who worked on the Manhattan Project had no idea what they were working on. They were told that it was for the war effort, and that satisfied them, and thus they didn't question what it was they were doing, but they knew that if they did it, the war would be over more quickly. And these would be hard things to replicate in our modern open society. Congress was not involved in any way, shape, and form, other than appropriating the money for it, but only a few congressmen knew what this project was. They had been told by Secretary Stimson and General Marshall that it was for the war effort and that they shouldn't inquire, and that was enough. So I think the Manhattan Project is rather unique in the American experience here, and it would be very, very difficult to recreate it, as much as we might like to be able to do these things again. Now we can take parts of it and perhaps do it on a scale that is similar, but this grand effort, which was a $2 billion plus effort at the time, if you transpose $2 billion into today's dollars, it's probably about $40 billion. It's about 20 times as big today. So can we imagine a $40 billion effort concentrated today on doing something and getting it done as quickly as it was then? And it's hard to think of what that might be. So in the end, I think the Manhattan Project will have to stand as a testament to very creative people under great pressure accomplishing a goal in an amazingly short period of time and helping to end a terrible war.